Hey everyone, for my indie game I needed a language for my aliens to speak. For a while I just described it like the alien speaks foreign language, but I realised that creating a consistent language would make it possible to have objects with text on them like signs and mats. So I spent a few days designing a fully consistent syntax for this language, and since I won't be able to fully explain it in the game, I decided to make this video. So sit back and enjoy as I walk you through the universal space language of Astralingua. My first decision for this language was to design it in a different way to most. Normally, a language develops naturally, as different people speak to each other, but for Astralingua, it's a universal language, which means it's designed to be communicated by many kinds of alien species. Since not every alien has a mouth or hands, Astralingua needs to have sounds that every alien can actually make. I played around with different pitches, but decided to just have 3 distinct sounds. And since there's only 3, each alien can decide its own way to communicate those sounds. The Konekomi are a humanoid alien species, and they hum or speak in 3 different pitches. They also have feelers, so we'll give them a special dialect that uses them. For now though, let's look at numbers in the language. Numbers are universal, but there's many ways to write them. English uses base 10, but computers use base 2 or binary. I did some research about unusual number systems and came across one called balanced ternary, which sort of reminds me of Roman numerals, so I went with it. Balanced ternary is base 3, which means each digit has 3 possible values. In ternary, you have 0, 1 or 2, but in balanced ternary, you have 1, 0 or minus 1. The value of each digit starts on the right and goes up in powers of 3. 3 to the 0, 3 to the 1, 3 to 2, and so on. What's interesting about balanced ternary is that you don't have a minus sign, instead you have a minus 1 digit. So minus 1 is just t. You can also put t after other digits, so the number 2 is written as 1t. The 1 is in the 3 column and the t is in the 1 column, so 3 minus 1 is 2. I think that's pretty cool. Fractional numbers aren't used that much, but I decided to make those possible as well. In English, to represent 1/2 you just say 0.5, so the 5 is in the tenths column. That's fine in decimal, which is base 10, but in balanced ternary it kind of sucks. 1/2 can be approximated as 0.11111, which is 1/3, or 1.tttt, which is 2/3. Neither of those is 1/2 or even close. Instead though, we can use fractions. 1/2 can just be written as 1 over 2, which in balanced ternary is 1 over 1t. That's it. It works for any number, even 2/3 or 2/7 or any other rational number. At this point I got the idea to use numbers to represent words. Technically you could put every English word in a dictionary and say their position in the dictionary one after the other. You get something like 36, 75, 192. However, you need something to separate those numbers, which would have to be an extra sound, so I created a solution that only uses the same 3 sounds. But before that, we need a way to write this language, so I came up with 3 simple characters for each sound that are distinct and unique. For each digit I use a number of lines, 1 line for 1, 2 lines for 0, and 3 lines for t or minus 1. I also added a tail to make it clear which direction it goes when it's written upside down. And these characters are all in Unicode, which is a big bonus, so you can write it in text. Now that we have our number digits, we need a way to speak them without an extra separator. So the solution I devised is a 3-step process. Firstly, you find a number matching the word you want to speak. So hello is 8. Then you convert the number to balanced ternary. Now comes the magic. We separate the number into 3-digit blocks, where the first digit indicates whether the block finishes a number. Let's look at hello, or 8, or 10t. There's 3 digits, so we separate them into blocks of 2, 10 and t. Then we add the extra digit that indicates whether the block finishes. The first block gets a 1 because the number continues in the next block, and the second block gets a t because the number finishes in that block. The last block is only 2 digits, t, t, so we can pad it with a 0 to make it 3 digits, 0tt. Now we have 110, 0tt. To get back the original number, You read each block until you find one that starts with a T, that means it's negative. Then you remove the first digit and put the other digits together. If you're confused, don't worry, this takes some practice. It's time to look at the words that match each number code. Obviously most languages have a lot of words, so for Astrolingua, I chose an easier process. I decided to focus on the most important words first, and ideally, the most important words should be shorter because that makes them easier to say, especially when we only have 3 sounds. If we look at our 3-step process for representing words, we can see that every time you add 3 blocks, you can represent a larger number. And the formula to calculate the highest number you can represent with 3-digit blocks is 3 to the power of 2n minus 1 over 2. That means 1 block can represent 0 to 4, so 5 numbers. 2 blocks can represent up to 40, 3 blocks up to 364, and 4 blocks up to 3280, which is more than we need. So the most used words should be from 0 to 40, since those will be 1 or 2 blocks, and the less used words can be 3 or 4 blocks. I took some inspiration from Chinese and Japanese and ignored filler words like the and is. The first 8 words are basic concepts like help and danger, and the next 16 words are for basic communication like hello and question. I specifically chose the number 8 for hello because it happens to have all 3 sounds in order, 1 1 0 0 T T, and I think that's useful if you have unusual ways of communicating them. To reduce the number of words, I made some of them more vague, like union, which can mean and, or group, or it can mean physically touching, depending on the context. One interesting decision I made is to not have a word for not, because it cannot not be confusing when you've not got multiple nots in one sentence. Wow. Instead each word is positive, like ready and unready, which means you don't have questions like, are you not ready? I also don't have words for yes and no, instead just use likely and unlikely, as in, what you've said is unlikely to be correct. Baka. After we get to 62, we have designed all of the linguistic words, but we're still missing words for actual things like tree and eye. I thought about the best way to generate all these words and decided to invoke the help of a large language model. 600 words later, I had cleaned up a lot of its responses, and we now have words for objects that different aliens might use in their day-to-day life. Words like force field, volcano, reactor core, skywalk, echo, nightfall. There's a lot of words here, but I can always add more words at the end if I need to. After I started playing around with this language, I noticed that numbers can be quite awkward to represent. Since each word is a number, we need separate words for the digits of a number. The number 27 would be encoded as 26, 27, 27, 27, and that is 18 digits in Astrolingua, which is quite long, especially when the word with the code 27 is only 6 digits. So I created 2 different solutions to fix this. Firstly, if you're writing, instead of encoding a number as Astrolingua, you can just embed it as is by using this special square bracket symbol. That means you can just put the digits directly in the brackets. I also added this angle bracket symbol, which lets you write fractions without using the word for division. But if you're not writing, you still have to say the number as words, so I added some special units. Just like in English, where you have megabytes and gigabytes, in Astrolingua you have saka, roka, kuka, nika, goka, haka, and chika. Kuka is 1 with 9 zeros, which in balanced ternary is 19,683. I took the opportunity to work on some standard units of measurement, since aliens wouldn't be using meters or seconds. I use Sirius A as a reference, which is the brightest star in the night sky, 25 times brighter than the sun. 1 Siri is the diameter of Sirius A, which is 2.38 million kilometers. If you use Chica, which is 3 to the power of 21, you can approximate a meter with 4 Siri over Chica, which is about 91 centimeters. Alternatively, if that's too complex, you can just use a foot to mean 30 centimeters. In my game, the main alien species you interact with is of course the Konekomi, who are kind of like humans, but they have feelers which are really important. Since they're a little bit more advanced than the other alien species, they have a more complex dialect of Astrolingua. The main change is that they move their feelers to change their tone. 1 line means uncertainty, 2 lines means it's neutral, and 3 lines means it's urgent. The symbols can be combined as well, so 1 urgent symbol means slightly urgent, while 4 question symbols mean very, very confused. So what is the result of all this? How does this language sound? Well, to show you, I created a simple sentence. Very, Astrolingua, joy, more, English. Can you guess what it means? Well, in Astrolingua it would sound kind of like this. That's all. I hope you enjoyed watching me speak about Astrolingua. If you want to follow my game Konekomi Castle, then you can wishlist on Steam. Currently the info on the Steam page is out of date, but that'll be updated with new screenshots and artwork very soon. Have a nice day.